Right, the next one of our shapes and applying our VSEPR theory is when we've got 3 regions of electron density around the central atom. Now, if every one of these bonds was identical, then the bond angle would be 120 degrees and the shape would be what we call trigonal planar. And so for this one here, planar, for this one here, methanol, it is trigonal planar because there are 3 regions of electron density and they are all bonding pairs of electrons. So that's how we phrase that. They're bonding pairs. So we represent that like this is our ball and stick. It doesn't matter if you don't get your angles perfect for your diagram. Now, at level 2, that would be enough. You'd say it's 120 degrees for each of them, and that's it. But at level 3, we need to understand that this situation here, this oxygen with its lone pairs and its double bond, is going to repel these 2 bonds, these 2 bonding pairs, a bit more than they repel each other. So it pushes them closer together. Therefore, this bond angle will be less than 120. Not a lot less, but it will be less than 120, which means each of these will be just greater than 120 because the bonds are not the same. If they're all identical, so for example, something like boron trifluoride, BF3, then if they are the same, it is 120 degrees. But very rarely will you get an example like that, so we need to show an understanding of which one of these would repel the others more. This being a double bond and having lone pairs on the oxygen is a bigger electron cloud, and so it's going to push the CH bonds away more than they push each other away. So it's got more repulsion than the CH bond. The CO bond has more repulsion than the CH bond. Our other example is when we've got 2 bound to it with a lone pair of electrons on there as well. It's still a trigonal planar electron cloud because it's still got the 3 regions of electron density coming off it, but it's a different shape. This is what we call bent or V-shaped. And it's because of those lone pairs of electrons. Now, lone pairs also repel a lot more. So a lone pair of electrons has a higher repulsion than a bonding pair. So therefore, this is going to push those 2 oxygens even closer together, so their bond angle will also be less than 120 degrees, which means, of course, your reflex angle will be greater than 240 degrees. But the key angle you want is the shorter angle. It will be less than 120 because of the repulsion of the lone pair of electrons being greater than the repulsion of the sulfur-oxygen bonds.